Welcome everyone. This is our third webinar for STEM Week. I'm Khalif, STEM lead at Mass Robotics. Mass Robotics is a nonprofit independent organization and a hub for robotics, AI, and connected devices. We aim to grow the robotics industry as a whole and inspire the next generation, which brings us to STEM Week. And so this year for STEM Week, we're highlighting different STEM kits and opportunities for students to get engaged with, for teachers and educators to get comfortable with, so that we can bring the next level of next batch of engineers and roboticists right into the workforce as they get into their high school and college years. So today we'll be talking about Soft Robotics Toolkit, and with me I have two of the main people in charge. So they're going to give you an overview of what is Soft Robotics Toolkit and some of the resources around it.
Great, thank you. Are we good to go now?
Yep.
All right, got it, Matt. Cool. Thank you everyone for joining. We're looking forward to this.
All right. Yeah, thank you guys. Definitely hope to be able to show you guys a little bit more about what we're doing in the soft robotics space. My name is Mac Cameron. A little background on me. I actually teach a few classes at MIT at Intro to Making, where we go over a lot of different technology from 3D printing, laser cutting, Arduino, coding, a little bit of molding, and then ultimately build robots. And then another one called Design for 3D Printing. Before that, I worked at Stratasys for a number of years, where I was 3D printing a lot of different educational applications. And now, excitingly, I'm working on the Soft Robotics Toolkit with Alex and Connor over at Harvard. And we're hoping to introduce a really, really unique, empowering, and diverse set of skills into the classroom. So looking forward to it, and thank you for having me.
And I'm Alex. My background, I come from the industry into now academia to Harvard, and worked at places like iRobot and Staples on some IoT stuff. So industrial design is my specialty. It's what I went to school for. So trying to create great product experiences, and now I'm bringing those skills here to Harvard, where we're working on some soft robotic kits for students and really anyone that's interested in getting into this kind of emerging field of robotics. And so we hope to share some great stuff with the world.
All right. So just to get started, I mean, really, we want to empower people to solve problems, learn creatively, and express themselves with soft robots. And if you're not familiar with what soft robots are, it's really a subfield of robotics in general, dealing with constructing robots from highly compliant materials, similar to what's found in living organisms. So making robots that feel more like nature, whether they be jellyfish, octopus, people's faces, but making robots feel real. And another term that is used often in this space is programmable materials. And if we just think about like this application here, which is actually from one of the Harvard labs, we're building a material with the purpose of controlling it with air, as opposed to with traditional electronics. And if we look at some of the applications of this, we're really able to do things with soft robots that are difficult, if not impossible, to do with hard robots. And a few examples are packaging and bio medicine, and it's really a field that we have found can bring in a really, really diverse set of skills and passions into this field, where a lot of times we're finding traditional robotics training and teaching are focusing on the hardware and the programming. Soft robotics allows us to bring on a lot of passions in biology and chemistry, and we really focus a lot on the materials, which we found can get a lot of people interested who aren't traditionally interested in soft robots. And we think that that is one of the reasons why this is going to be important for you guys to learn about and introduce in your classrooms moving forward here. So very briefly, just on the team, I currently teach at MIT. Had some experience at Stratasys, like I had mentioned, and then Alex talked a little bit about his background. Connor, who's not with us today, is a professor over at Harvard, and he runs the Harvard Biodesign Lab, where he has a huge amount of experience and breadth in the soft robotics space, including lots of different wearables for creating and solving problems across the board in this space. So he's been very empowering supporter of this. And then Alex, do you want to talk a little bit about the history?
Yep. So the Soft Robotics Toolkit, I don't know if anyone has come across this, but it's been around since 2014, and it's probably one of, if not the most popular websites for learning about soft robotics. We have competitions that have been extremely popular in the past, and that has been like the basis of the Soft Robotics Toolkit website, to teach and educate around this area, but also to get people to innovate and share their ideas. So we've had over 800 competition participants. If you want to go to the next slide, Mac. And right now it has probably about 3 million page views at this point. This is a little outdated, but we've have contributions from 24 different research labs around the world, been visited by all the countries, and average about 300 visits per day. And it's still quite a popular website, but in like a very niche community of people that come across this. And our contributors right now are people that have been uploading and coming to the website for information, or hobbyists, high school undergrads, and researchers predominantly, with undergrad and researchers being the ones who are contributing the most type of innovation and technology, because that's really where this field of robotics is and has been for the past 10, 20 years. It's been around for quite a while, but it's finally coming to more of a mature stage, and that's why now we wanted to get into this area of bringing it into a younger audience. In 2016, we started making materials for workshops for students, just putting together very simple things. And we thought, how can we package this into a product? Because we were getting told by parents and students themselves, like, where can we buy this? Where can we buy the kit? And we would always direct them to the website, where you can find material lists. But it seemed like there was kind of people wanted it to be easier. Basically, they want to just buy everything in a box. And so we've come up with this first product. It's called the Soft Robotic Gripper. It's quite simple. Grippers are really popular form of soft robotics right now. There's a lot of innovation a lot of innovation happening around gripping, and soft robotics lends itself really well to this type of application. And so our kit goes, we're calling it, manual electronics programming. It goes from no tech, low tech, and then up to the programming we're calling high tech. And you can start with manual. If you go to the next slide there, Max. So this is about really learning about casting, which is kind of one of the most popular, or like, areas within soft robotics. Like, there's a lot of casting and using silicones. Silicone is a really popular material, along with fabric, and of course all other things that have flexibility to it. But so we teach and we introduce silicone and casting to students, and this here is a very simple, one-part mold. Molds get much more complex, and there can be a whole lesson around this, but creating different molds that apply themselves to different forms of actuation, whether it be like pneumatic. For instance, this is tendon actuation, meaning that there's a string that runs through the finger on the gripper, if you saw on the last page. And that's why we say that this is refers to biology or to nature, and how you can draw inspiration from there, and like how our finger works with tendons. And then going on to electronics. And so this is, soft robotics also incorporates hard, rigid kind of materials as well. We haven't quite got to the level of innovation where we're making soft motors and soft PCBs yet. There's work being done there, but we still need to incorporate these things, and we want to kind of, in this kit particularly, introduce students to kind of the beginnings of that, and if they haven't had experience there. So basic circuitry there, and then moving on to programming. And this is just using the typical Arduino that's quite common, and we have a proximity sensor that's at the end of the gripper that that allows the students to program distance for when the gripper will automatically close and how long it'll close for. And then how it works is with a motor, and you can see the pulley that's just on the opposite side of the Arduino, and that's a really common form of actuation that we like to draw the similarity of what's happening here in this gripper kit to more complex things that happen in the biodesign lab, which are we create a lot of exosuits in the lab, meaning like wearable robotics, and those use a lot of tendon actuation as well. And so you can kind of show students how something quite simple as this, it's very visual, easy to understand. It's just a pulley that's pulling on in this case fingers, can also be applied to much more complex robotics being used in military applications. And so in here we have build instructions, and we had an educational magazine that we were including some more information around soft robotics, bio inspiration, things like that. The instructions very much inspired by Lego, large images, not too much text, but we've moved on to including curriculum instead of the in the box magazine, because we found the kids or the students really weren't that interested in it as much, and we thought we can give them a richer learning experience if we create a curriculum around this excuse me, and have them go through like activities and lessons and challenges and really be hands-on with the equipment or the products. We've done quite a bit of outreach since 2014 when we first started. I've recently been to India, well, not too recently, but before COVID, I went twice since starting at Harvard for a month each time, getting this stuff into less privileged communities, and trying to spread the word about this. And we're having our first large-scale pilot happening in the beginning of next year in February. And so we are in the process of producing with a manufacturer in India about 120 of these kits that are a bit different looking. I can actually quickly just hold up. It's similar to this now is kind of what it's looking like, obviously in the completed built form. And we're producing these to work with 6 schools in India, and we're running it all remotely now for obvious reasons. And yep, we hope to get a lot of great feedback on that. We'll be writing papers, hopefully. And here's just a video I can talk through here. So this is the last time I visited, or no, the first time I visited India. We ran this 3-day workshop with students there, and sorry for the quality. It's just because of the connection, or at least on my end, it's a bit choppy. But this just kind of shows students building and interacting with the products. So like the highlight of the kit is for sure the casting of the silicone. It's very kind of new. Everyone's excited about that section of it. And then getting into electronics, it's much more familiar and more of an assembly process. But they're learning about degrees of freedom and how they apply to soft materials as opposed to rigid materials, and basics of material science, and how these can be used in everyday applications and obviously industrial applications. But yeah, everyone in this workshops and so far in general have found this quite exciting, and it's definitely a different perspective on robotics than I think what's out there now. And we hope to continue to bring more exciting projects out of the lab and into classrooms and spreading the word here. I don't know if you want to fast forward, Mac. It's kind of long.
Yeah, no. I just went through this last week. It is something completely unique and interesting. I think I think education and making stuff like this is going to continue to be very exciting and important as we continue to focus on sustainability and really unique and interesting applications in robotics. So I'm a big fan of this. I can't wait to continue to incorporate this stuff even into the classes that I'm teaching over at MIT. And I think as we can see, it's diverse in the the age group that could benefit from this greatly. So we would love to take some questions. We also really encourage you guys to check out the Soft Robotics Toolkit website. I can click through it a little bit, but also we would love to just speak to you more. We're looking to constantly be talking to students and teachers and makers around the world to see if they would like to collaborate or learn a little bit more about what soft robotics can do, and we're hoping to make it easier for everyone.
Matt, do you want to just quickly click through the resources for educators on the website? That might be an interesting one.
Yep. Yeah, so I'll just quickly go through two things. So on the Soft Robotics website, there's the components section where if you click into sensors or actuators, you have a lot of different great content of how to create different actuators. Again, a lot of this stuff is really cutting edge. The sensors as well, how to build and thinking about making wearable, electronics, and then the resources for educators. We have, again, a huge amount of resources here, from projects to how to actually produce different pieces with videos and files actually where you can be downloading things. So we hope that this was valuable, beneficial, and really it would be great to connect with you soon. And yeah, thank you guys again.
Thank you guys so much for coming in. Just one question so far that came in that was just what's the age range?
So we've been trying not to give any like hard age range because we've had interest from undergrads all the way. We've run workshops with fourth graders as well with the same materials, so it's wide ranging. But I'd say the most common, or the age range that probably finds this the most interesting has been about like 10 to 14-year-olds. So middle to maybe freshmen, even sophomores in high school. It really depends more on your prior experience in robotics and electronics and things like that, because the Arduino is kind of a whole thing to learn on its own as part of this kit. So we're hoping to work on stuff that makes that side of things control easier. We are working on it, but yeah, we found that especially the younger students have been able to do the first section, manual, where you cast the fingers and you create just by pulling the strings, you can create the gripper. That has worked well, and they seem to grasp the concepts that are going on, and then all the way up to freshmen, sophomores in high school.
All right. Next question: how long is a typical class or a session, and does it take some time for the gel to set?
Yeah, the silicone takes about 30 minutes, so it can be done. We've picked this silicone specifically to be done in like a class period, and be able to like demold it and use it. So yeah, it takes 30 minutes, and then a typical class, we've tested many different versions of the curriculum that we've been building really over the past year, and the one that we're running in February in India, each class is about 60 minutes long, and this kind of boot camp workshop will be run over about 8 weeks. So we've really created a lot of content around this that you can, really have a full boot camp type course probably within a class or our school.
Next question: how do we get our hands on a kit, and how much does it cost?
So we're not selling anything. We're currently a research project within Harvard, and so right now we're focusing on working with schools and hopefully potentially raising some more grant money, and then producing more of these kits down the road. So there's no price tag right now, and yeah, we are getting 120 of the kits made. We plan on getting or using about 70 of them in India, and so the ones we have left over will be shipped here. And we're happy to, we want to work with schools here in the U.S. as well. That's been our goal from the beginning, is kind of split the efforts between working in India with some less privileged communities, and then obviously working here in the U.S. So if you want to get in contact with us, that we'd be happy to have a talk and see about setting up a boot camp or workshop in your school.
So as an educator, how can we learn more about what soft robotics is about in order to teach it to our students?
Yeah, so that's definitely been one of the biggest challenges for us. We do have an educator on our team. She's going to be running the boot camp in India. She came over from India, and she's put together a kind of professional development resources. So basically a whole workshop for teachers that we're working on. So we're hoping to get that as possibly, a resource that can be like watched through videos and whatnot, and have documents around that. Right now, she's kind of teaching that to the educators in India, and so we're working on developing that further, and like the basics of what you need to know to teach these things. But there's not a lot out there, I'd say, beyond kind of what we're doing. So that's kind of that's why we're creating it, and I'd say our website's probably has probably the best resources, especially from an education standpoint.
Yeah, and just to add on to that, if your school or you're part of a makerspace has a makerspace, this is like a really nice complement to what's already going down in makerspaces, because it brings in a whole new field of innovation and invention. Using the soft compliant materials and being able to do stuff is really brand new, generally speaking. And there's a lot of things that you can do with soft robots that are very, very difficult to do any other way. So yeah, I would really encourage you guys to reach out to us and just shoot us a message if you are interested, because we have hours and hours of content that, if you are interested in incorporating it into your school, we have the content and the train the trainer program being worked on right now, and we want to work with more people. So please contact us.
Awesome. Next question, if we have multiple classes, can we break down the electronics, and can we get silicon locally?
Yep. So the curriculum is meant to be kind of flexible, because just over experience, we find that everybody has a different approach to what they think they want to teach to their students and what's appropriate for each class. So I'd say we can, that the electronics can be broken into different sections, if I'm understanding the question correctly. And then for the silicone, if you're in Boston area, there's a company called Reynolds Advanced Materials, I believe is the full name. It's over in Alston, and they sell this in their store. You can also buy it on Amazon. It's called, the company that makes the silicone is called Smooth On, and they have a wide array of different silicones. They kind of have a monopoly kind of in the soft robotics space right now for silicone. They're the only one that offers anything that's even close to like good quality for these applications. But you can also, if you go on the website, the Soft Robotics Toolkit website, which is not the easiest to navigate, sorry about that, and you go to projects, I think it is Mac. Go
Okay.
to showcase, then projects, and then go down near the bottom to edible soft actuators. Right there, yeah. And then click on fabrication over on the left at the top. Yeah, and then if you follow this recipe, you can just you can go to the grocery store and buy corn syrup, gelatin, and water, and actually make like a homemade recipe like at home of like what we call bioplastic or biosilicone. So it's kind of fun. It's basically just a homemade recipe for making gummy worms and gummy bears, and it actually produces similar results to silicone. And it's pretty fun to do in classes. It takes a bit of trial and error to get the recipe right, but it's good. It's a fun activity, and it's much cheaper to just go through a bunch of corn syrup and gelatin, because Smooth On is not very expensive, but it's quite expensive, and it's been one of the downsides for us trying to get into schools, because we know that budgets are tight, and this is a costly replenishable that would have to be basically bought every time you want to run the kit or the workshop, because without the fingers, there's no real point.
So just that's the only piece that has to be replenished. Everything else can be taken apart again and reused.
Yep, that's the only piece that's needs to be remade. So it's these silicone fingers here. Everything else, proximity sensor up here, this comes out. The rest of it, plastic parts, and we've been working with the manufacturer to create our own Arduino in here. It's probably hard to see in the camera, sorry, but they have some snap-ins for the cables that are much more robust than what we had on the prototype that was shown during the presentation. And so we've tried to make this as reusable as possible. But yep, just the silicone is what needs to be replaced every time.
Next question, do you work with nonprofit agencies?
Do you have an answer for that, Mac?
Yeah, of course. Definitely looking forward to just expanding soft robotic education. So please reach out. We're open to opportunities and co-host different events in this space. So yes, please.
Awesome. Any last questions? I think we hit most of the ones that were already in. But if you have any last questions, I'll give you a moment to write them in. Otherwise, as they keep saying, they have their emails right on the screen. Make sure you get in contact with them. If you want to rewatch this and you want to, get a better grip of it, we'll have recordings of this on the website along with the other two webinars we've done this week. We have one more webinar of this style tomorrow with BrainCo. They make a prosthetic hand, and they have a new STEM kit that they're rolling out. But I don't see any more questions, so I think we're all set. All right, thank you very much, Mac. Thank you, Alex. It's been fantastic. It's great learning about this.
All right, thank you so much.
You.
Appreciate it. Have a good one.